Namaste to all, welcome to my channel MA Tuitions. If you are watching my channel for the first time, don't forget to like, share and subscribe. And don't forget to press the bell button, then only you will get the notifications properly. The last class we were discussing about the chapter polynomials and the last exercise, exercise 2.3. Today we will continue with the same exercise. Here is your third question. Okay. Obtain all other zeros of 3x raised to 4 plus 6x cubed minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and negative root 5 by 3. So you have already studied about the factor theorem, remainder theorem and all, isn't it? If you have a polynomial p of x, and if you have two zeros like alpha and beta, then x minus alpha and x minus beta are the factors of this p of x, isn't it? If alpha and beta are the two zeros of a polynomial, then x minus alpha and x minus beta are the factors. So how can you write this zeros of root 5 by 3 and negative root 5 by 3? You have given the polynomial p of x as 3x raised to 4 plus 6x cubed minus 2x square minus 10x minus 5. Okay, this is given. And you had given two zeros also. So we can write the factors as x minus root 5 by 3 and x plus root 5 by 3. These both are the factors of this p of x. So if these two terms are, or if these two polynomials are the factors of p of x, surely the product must be a factor of this polynomial. Surely the product should be a factor of this polynomial. So this is of the form a plus b into a minus b. Am I right? What is meant by a plus b into a minus b? A plus b into a minus b. You have studied the identity just like this. A square minus b square. Okay. A plus b into a minus b is a square minus b square. So here also we can write x square minus root 5 by 3 whole square. So you will get x square minus 5 by 3. Otherwise, we can write 3x square, cross multiply with this 3x square minus 5 is a factor of this particular polynomial. Got it? 3x square minus 5 is a factor of 3x raised to 4 plus 6x cubed minus 2x square minus 10x minus 5. We need two more factors, isn't it? This is a polynomial with degree 4. Since the degree is 4, it has two more. 4 zeros should be there. Otherwise, 4 factors should be there. So we have got already two of them. We should find out the other two. So what we want to do? We want to just divide. Okay. Then we are going to divide 3x raised to 4 plus 6x cubed minus 2x square minus 10x minus 5 divided by 3x square minus 5. Okay. Here we need 3x raised to 4. So I am multiplying with x square. Then you will get x square into 3x square is 3x raised to 4. X square into minus 5 is minus 5x square. Right just below the term of x square. Okay. Then subtract. You just change the sign. Then you will get 6x cubed. Here it will be plus 3x square minus 10x. Here we need 6x cubed. So I am multiplying with 2x. Then it will be 2 into 3 6. X into x square is x cubed. 2 into 5 is 10 minus 10x. So I am writing here minus 10x. Again change the sign and subtract. So it will be 0. Here you will get 3x square and this is also 0. Then you can write this minus 5 here. Then you will get, here it is 3x square minus 5. So just multiply with 1. You will get 3x square minus 5 will be 0. So here we got the quotient or the factor as x square plus 2x plus 1. This can be changed into a linear polynomial. How can you do? This is the expansion of a plus b whole square. This is of the form a plus b whole square, a square plus 2ab plus b square. Otherwise, you can split the middle term. So I can split this with x square plus x plus 1. This will be okay. 2x can be written as x plus x. And take the x outside from the first two terms. That will be x plus 1. Here also x plus 1 is there. So we can take this x plus 1 outside. Then you will get, here one x is there. Here one plus 1 is there. So we will get x plus 1 into x plus 1. So we have got all the factors or all the zeros. Zeros are if x plus 1 and x plus 1 are factors. If x plus 1 is a factor, what can you say? X equal to negative 1 is a 0. that the other factor also x plus 1, so x is equal to negative 1 is other 0. So we have got the 4 zeros. 2 of them are already given, root 5 by 3 and negative root 5 by 3. The others we find out as x equal to negative 1 and x equal to negative 1. Got it? Next question. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and remainder were x minus 2 and negative 2x plus 4 respectively. Find g of x. So, we have given a polynomial p of x. P of x is the polynomial which is given equal to x cube minus 3x square plus x plus 2. This is our polynomial. And we want to divide this polynomial with another polynomial. That polynomial is g of x that we don't know. Okay. We want to find out the divisor g of x. We don't know. We have to find out. Then the quotient and remainder is given as x minus 2 and negative 2x plus 4. So we can write quotient of that polynomial q of x equal to x minus 2. And what about the remainder r of x equal to negative 2x plus 4. These all are the given condition. We want to find out the g of x. We have already studied in the last class that a division algorithm for polynomial is there. What is that? Which is p of x equal to q of x into g of x plus r of x. This we have studied. So we can substitute the values in this, isn't it? So we will write p of x as x cube minus 3x square plus x plus 2. This is our p of x. G of x is not given. Sorry. Here first I want to write q of x. Q of x is x minus 2. Okay. Q of x is x minus 2. And into g of x. G of x is not given. Plus r of x means negative 2x plus 4. Okay. Then what we want to find out? We want to find out this g of x. So we can take all these things into this side. So it will be x cube minus 3x square plus x plus 2. Take these two terms into this side. Then minus 2x will be plus 2x. Plus 4 will be minus 4. Which is equal to x minus 2 into g of x. So you can write x cube minus 3x square. This x and 2x, x plus 2x will be 3x. 2 minus 4 will be minus 2, which is equal to x minus 2 into g of x. Okay. Then we want to take this x minus 2. Here x minus 2 into g of x is there. So we can divide this x minus 2 here. So x cube minus 3x square plus 3x minus 2 by x minus 2 will you give this g of x. So what we want to do? We want to divide this x cube minus 3x square plus 3x minus 2 by x minus 2. Then you will get the g of x. That means the divisor. We can just divide x cube minus 3x square plus 3x minus 2 divided by x minus 2. Okay. We need x cube, so we are multiplying with x square into x is x cube. X square into minus 2 is minus 2x square. Just subtract. It will be 0. Here it will be minus 1x square. And write the 3x here. Then you will get plus x. X into x is x square. Here you need minus 1x square. So I am writing here minus 1. Minus x into x is minus x square. Minus x into minus 2 is plus 2x. Then again subtract, you will get 1x minus 2. So multiply with 1, then you will get x minus 2 and the remainder is 0. Okay, so g of x will be x square minus x plus 1. Okay, so what we have studied? We have studied the algorithm of division for polynomials that we write here, and we substituted all the values given. That means p of x, quotient and remainder, and just rearrange, and we find out g of x by dividing this major polynomial with the x minus 2. Then you got the polynomial g of x as x square minus x plus 2. Clear? The last question of that exercise, for fifth question, give examples of polynomials p of x, g of x, q of x and r of x which satisfies the division algorithm and the following conditions. Okay, so you had given 3 conditions. According to this, you have to find out the polynomials p of x, g of x, q of x and r of x. So P of x we know the main polynomial that we want to divide, isn't it? Or the dividend is the P of x. What about G of x? G of x is the divisor and Q of x is the quotient. R of x is the remainder that you have studied according to the division algorithm of polynomials. So the first condition is degree of P of x equal to degree of Q of x. The first one we are going to do. This is merely your logic. You can find out by yourself. Okay, I'll help you now. Degree of P of x and degree of Q of x is equal means if I am dividing a particular polynomial. Here is the polynomial P of x. And dividing this with another polynomial G of x. Surely you will get a quotient here Q of x. Degree of this and this must be equal. That is our condition. The degree of Q of x and P of x must be equal. Or in other words, you can say that if you are taking a polynomial just like 2x square plus 4x plus 2. If I am writing a polynomial just like this. And if you are dividing a polynomial with this polynomial, if you are taking this with x plus 2, if you are dividing this with x plus 2, then you will get a quotient here. Its degree will be less than this, isn't it? So if you need x square here, surely you will multiply with x here, isn't it? So you cannot find any of such polynomial if you are doing like this. So what does it mean? If you need a polynomial, the polynomial quotient Q of x as the same degree of this, we should not take any x or y here. Okay, if you are taking a polynomial with variable x, you should not take any polynomial which contains any x or any term of x. Got it? So we have to divide this polynomial with any number. Then only you will get the degree as the same. Okay. So I am taking here the divisor as 2. Then you will get x square into 2. It will be 2x square. Subtract 0 will come 4x. Then you are multiplying with 2x. Then you will get 2 into 2 4x. Again you will get, and write this 2. Then you can write 1 here. Then you will get 0. So if you are taking any number here, you will get the degree of both quotient and the dividend as same. Understood? Whatever may be the polynomial you can take, that's not a problem. But if you are taking any polynomial inside this or as the dividend, you have to take a number without any x or any variables. Then only you will get the quotient and the dividend with the same degree. Understood? So here is the one example. Any other you can choose as your own. Got it? The second condition is degree of Q of x equal to degree of R of x. So if you are dividing this P of x with another polynomial G of x, then you will get a quotient Q of x and a remainder here R of x that you know by division algorithm. So here we need the degree of Q of x and R of x are same. The degree of this polynomial and this polynomial must be equal. Okay. So what we want to do is you take any polynomial as your wish as P of x and a polynomial with degree less than this as the divisor G of x. Okay. So we will do one example just like this. X cube plus 3x square plus x plus 1, and I am going to divide it with x square plus x plus 1. Okay, x square plus x plus 1. You can divide, then x will be x into x square is x cube. X into x square is x into x is x square. 1 into x is x. Subtract 0. 3x square minus x square is 2x square. Here it will be, this will be 0 and plus 1 is here. So you can multiply with 2. Then you will get 2 into x square is 2x square. Then 2 into x is plus 2x. 2 into 1 is plus 2. Subtract, you will get, this is 0, minus 2x, then you will get minus 1. So you got the remainder as 2x minus 1. Am I right? Here the quotient is x plus 2 and remainder R of x is negative 2x minus 1. Am I right? So what about the degree of Q of x? Degree of Q of x is 1. The highest power is 1. Here also 1. Here also degree is 1. So you got the polynomial as just like this. So what you have learned from this example, you want to take any polynomial as any degree as your wish, no problem. But if you are considering any divisor for this, you have to make in mind that the degree of this should be less than the degree of this p of x. Then only you will get the degree of quotient and the degree of remainder as the same one. Okay, so you do by yourself with another examples. Okay, then only you will understood. The last section is degree of r of x should be equal to 0. So you are dividing this p of x with g of x. So you will get a quotient here q of x, and you will finally get r of x, a remainder. Here the degree should be equal to 0. What does it mean? It does not contains any variables. That means the degree of r of x equal to 0. You cannot find out any variable in this r of x. It will be some constant. Okay. So moving on to an example, I am taking a p of x as x square plus 6x plus 4. I am taking a quadratic polynomial and dividing with them with a linear polynomial which is x plus 2. We can divide with this. Then you can find x into x is x square, x into x 2 is 2x. Subtract, you will get here 4x plus 4. Then you will find plus 2. You can find out 2 into 2. Sorry, here you can take 4. Then only you will get 4x here. 4 into x is 4x. 4 into 2 is 8. Then you will get a remainder as negative 4. So in this we have got a constant, not any variable. We cannot find any variable in this. So if you are doing just like this, you will get the degree of the r of x equal to 0. So here r of x is negative 4. R of x equal to negative 4. And what about degree? Degree of r of x equal to 0. You cannot find any variable in this. I told you no. So what you have studied from this, if you are taking any variable, any polynomial p of x, if it is a degree of 2, so you can split into a linear polynomial of 2. If you are taking it with a degree of 3, you will get 3 linear polynomials as its factors. So just like that, you want to be careful. Then only you can divide just like this, and you will get the remainder, the degree of remainder as 0. Okay. So we have completed our chapter 2 polynomial successfully, isn't it? So go through the chapter, and if you have any doubt, as always, you please make it on my comment box and follow my channel, and please share to the other students. Thank you so much for watching. We will see you with the next video with the next chapter. Thank you so much.